Every Java developer has crashed their app with a Stack Overflow error or out-of-memory error. But do you know why they happen in different places? Let's break down heap versus stack memory. Stack memory is where Java stores method frames, local variables, and primitive types. Each time you call a method, Java pushes a new frame onto the stack with all its local data. It follows last in first out access, so when the method returns, that frame is automatically popped off and deallocated. No garbage collection needed. Stack is fast, predictable, but limited in size. Heap memory is where all objects and their instance variables live. When you use the new keyword, Java allocates space on the heap dynamically. Unlike stack, heap memory isn't automatically cleaned up when a method exits. Instead, the garbage collector runs periodically to reclaim unused objects. Heap is much larger than stack, giving you flexibility for complex data structures. Here's the critical difference. Stack memory is thread-specific. Each thread gets its own stack, so local variables are never shared. Heap memory, on the other hand, is shared across all threads, which is why you need synchronization for shared objects. Stack has a fixed, limited size. Recursive methods or deep call chains trigger Stack Overflow error. Heap is larger, but can still run out, causing out-of-memory error when you allocate too many objects. Remember, stack is fast, thread local, and automatically managed for method data. Heap is shared, flexible, and garbage collected for objects. Master both to write efficient, error-free Java code. Practice explaining this in your next interview. Want to get better at answering questions like this? With Interview Mentor, you practice real interview questions out loud. You get personalized feedback and a grade on every answer, and you can track your improvement over time.